All right, Algebros, what's up? It is time to put these systems to work and see some applications for them. So the first thing we're going to work on in this video is just writing systems, okay? So taking a application problem, a situation, okay, and writing the two equations that go along with it. Most of you picked this up pretty quick, all right? So no worries. So here we go. So first thing I want you to think about, okay, is the question here: what are the two key phrases that will help in creating a system of equations in a word problem? It's two key phrases that I want us to come up with here. They're going to help create them. They're not always going to be perfect, but they'll at least help you think about what you need. All right. So this is the first thing on your notes. So it says Lily bought 8 pounds of fruit at the grocery store. She bought a mixture of strawberries and bananas. Strawberries were on sale for $1.99 a pound, and bananas were 99 cents a pound. If she spent $10.92 on the fruit, write a system of equations that could be used to find the number of pounds for S, strawberries, always important to pay attention to your variables when we do this, and B, bananas that she bought. Okay, so 2 points of importance here, all right, that you want to think about in the problem. Well, what is it really about? You know, kind of what's being calculated, things like that. In this case, the two first important points to pay attention to are the pounds of fruit and the cost of the fruit. Okay, so kind of two separate things. So try to keep those separate in your mind, because that helps us develop these two little questions that we're going to think about. So if I'm thinking about pounds of fruit or cost of fruit, pounds of fruit, I'm thinking physically the amount here. Okay, so the question that I want to go with that, as opposed to the question that I want to go with cost. Okay, so physically, you know, what's the amount as opposed to the cost amount? That leads us to our two questions. If I want to know physically the amount of something, I want to know how many of them there are. Okay, so like how many pounds of fruit? That's our first out of our two key questions. So then the other one, hopefully you can figure out, if we're talking about money, okay, it's not always money, but it very often is money. We're talking about how much. How much did it cost? So then when you're writing your two equations, you have to try to keep those two things separate. So you want to think about, okay, well, how many, in this case, strawberries and bananas were there? So how many pounds? So anything that has to do with a pound, okay, the actual measurement of a pound will go in our first equation. And then anything that has to do with money will go in our second one. So then if you think about how we want to write this, well, she bought 8 pounds. 8 pounds is her total. Remember, anytime you have a total, that means it's probably going to equal that. Well, and how do you usually find totals when you're buying things? You take two things and add them together. Well, what two things did she buy? She bought strawberries. She bought bananas. So our first equation, she's putting them together. She bought some strawberries. She bought some bananas. You add them together, and she bought 8 total pounds. Again, that is how many pounds did she buy? Now, anything about is, well, how much did it cost? Okay, well, it tells us that too. She tells us that she spent $10.92. Again, that's a total, so I know I need to have 1090 equals 1092. Well, then it's $1.99 a pound for strawberries and 99 cents a pound for bananas. So keep in mind, if these are our variables that we're using, we have to use the same variables in both equations. Now we just need to add the numbers to them. So if 1092 is the total, really easy. Just put $1.99 with the strawberries and 99 cents with the bananas, and there's your system. Okay, so for right now, all we're worried about is just kind of reading through the scenarios and writing the system. So we'll get to solve them here in just a little while. Okay, on to the next one. This one is going to test you, see if you know your coins. I know you guys don't use coins all that much anymore, probably like we used to. All right, but this still shows up on EOC like this every now and then, so we got to make sure we remember them. So it says Mark has $4.95 in quarters and dimes. He has 3 times as many dimes as quarters. Write a system of equations that can be used to find Q, the number of quarters, and D, so Q, so quarters, you can kind of see it behind there. I'll move that in a minute. And D, the number of dimes. So let's make sure we know our coins. Start with a penny. A penny, of course, is 1 cent, but remember when you write that, it needs to be 0.01. Okay, 0.01 is a penny, because a dime is 10 cents. So notice the difference between the way those two are written, right? A dime is 10 hundredths, so 0.10, and a penny is 1 hundredth, so 0.01. Okay, then also don't forget about your nickels. Nickels are 5 cents, so they're 0.05, 5 hundredths, and of course your quarters, 25 cents or 25 hundredths. Okay, those are the most common ones. We all know there's things like half dollars and special dollar coins, stuff like that, but those are really the only 4 that we need to worry about, especially in this case, because all we're worried about are quarters and dimes. All right, so again, let's think about how many. And this one can be a little confusing because this is what you need to think about right here, this sentence. He has 3 times as many dimes as he has quarters. That means, okay, he has more dimes than he does quarters. So think about this. If he had 3 quarters, what would you do to that to figure out how many dimes he would have? Well, that's probably a bad example to use 3, but if he had 5 quarters, let's do that. If he had 5 quarters, think about, you would have to multiply it by 3 to get the number of dimes. That means that equation is dimes equals 3 times the quarters. Just read it again. 3 times as many dimes as quarters. So think about what he has more of. What he has more of is going to go on its own, because then you're going to use what he has less of to do the calculation. Okay? So a lot of people will do this. They'll have Q equals 3 times D because it says 3 times as many dimes. Don't do that. Okay, dimes is what he has more of. Whatever you have more of is going to go by itself. Then, just like we did on the last one, you just got to add in the money for the how much equation. So in this case, we're going to add the 25 cents to the quarter, the 10 cents to the dime, and it equals the total of $4.95. It doesn't matter what order you have these two in. Those two could be switched. It's addition. So if you had 0.10D plus 0.25Q, it doesn't really matter. Okay, it's addition, so the order doesn't matter there. All right, so make sure you know your coins, just in case that comes up. Okay, and then really think about this sentence again. 3 times as many dimes as quarters. So he has more dimes, so that's the one that's by itself. All right, next. This one is just, we did some stuff like this earlier in the year. It's just translating. So one number, x, because we don't know what the number is. So this is kind of similar to that last one, is, remember is an equals word. 3 times as large as another number y. Well, times and 3 times another number y. So we know that's got to be a 3y. So we know this is an equal, that's an x. We've got a 3y. So that one is a pretty simple equation right there. That's just x equals 3y. Now, notice I've marked out the how many and how much over here because they don't really help in this situation. This is really just translate it. There's not a how many and how much here. So like I said, it's going to help. Sometimes it's not going to be perfect. Okay? Next sentence says, their sum is 128. Well, who's there? Well, there is referring back to the two numbers that we don't know, so that's x and y. Sum, of course, is an addition word. Is an equals word. So if we translate that, that should translate to x plus y equals 128. Okay, so the first one, x is 3 times y. Their sum, so there is the x and the y, is 128. There you go. Hopefully along the way you're kind of looking at these and thinking, oh, I would use substitution for this, or oh, I would use elimination for this. Okay, that's kind of where you want to be going with this, and that's kind of what we'll get to in the next video. All right, a couple more. Rogers Theater sold 210 tickets and collected a total of $1,530 in ticket sales for the Sunday matinee of Sound of Music. Admission was $11 for adults and $5 for children. Write 2 equations that will be used to find the number of adult tickets, x, and the number of children's tickets, which is y. Okay, so how many? Well, out of the 2 things here, the 2 things are tickets and money. Okay, which one of those can we physically, figure out how many of them are there? Okay, how many of them? Well, that's the tickets. So there's 210 tickets. Well, how did they, what type of tickets are there? Well, there's adult tickets and there's children's tickets. So if we sold a total of 210, we have those 2 types. So we need to add them together. So very simply, x plus y equals 210. That's how many. Notice there is no money in there at all. So then let's talk about how much. How much did it cost? How much did they earn? That kind of stuff. Okay, well, they collected a total of $1,530, so that's got to be equals. Then we have 11 for adults, so for every adult is 11. So adult is x, so these 2 should go together. $5 for children, which is y, so those 2 should go together. Put those together, there's your equation. I just took the 0.00 off of it, just made it a little bit shorter. If you leave it on, it's fine too. But 11x plus 5y equals 1530. There's your how much. Okay, again, look at that one. Think about which method would you use. All right, one more. A rectangle is 7 inches longer than it is wide. There's another one of those sentences you're going to have to decipher here. If the perimeter is 72 inches, how long is the rectangle? So write a system equation that can be used to find the length L and the width W of the rectangle. Okay, there's a formula. If you read that hint there, it says write the formula for perimeter of a rectangle that you're really supposed to remember. Okay, and if you think about a rectangle like this one that I have drawn up here, if I'm doing perimeter, I'm adding all the sides up. So how many lengths are there? Well, there's 2. How many widths are there? Well, there's also 2. So if I add those 2 together, then I have my perimeter. This is that formula that I'm talking about that you're supposed to remember. So 2P plus, 2L plus 2W will equal 72. Where am I getting the 72 from? It's the perimeter. Is, so equals, there's the is, 72. Okay. So now I got to go back to that first sentence again. A rectangle is 7 inches longer than it is wide. Okay, 7 inches longer than it is wide. So longer is the bigger one. Okay, compared to the 2. Longer is the bigger one. So if it's 7 inches longer, okay, that's going to be addition. So I need to take that 7 and add it to the width. Because if I knew the width was 10, all right, and I wanted to know the length, I'd have to add that 7 to it. So your equation is L equals W plus 7. Most people, if they have a happy accident, it's going to be the other way around. They're going to have these two switched. Don't do that, all right? Again, pay attention to which one is bigger, longer, that type of thing. In this case, it's length, so it would be longer. So longer, okay, than it is wide. By how much? By 7. And there you go, all right? So hopefully that's starting to make sense to you on writing the equations from the scenarios, okay? And I'll see you soon.